Conductors. Some conductors conduct better or worse than others. And what does that mean? Well, conducting means material allows for the free flow of electrons to varying degrees. Some are more free than others. The flow of electrons is just another name for current, right? Because we define current as delta Q over delta T, and the charge carriers, which give you the Q, are electrons. Another way to look at this is some conductors resist current to a greater or lesser extent. We call this resistance R, capital R. It is measured in ohms, which is noted by the Greek symbol omega. So how do you think this resistance will affect current? And notice, resistance looks like it's the opposite of conductance, doesn't it? Raising resistance will reduce current flow, and raising voltage will increase the current. We will combine these two relationships into what is named as Ohm's law. That means current is equal to voltage over resistance. So you can see if you raise V, current will go up, but if you raise R, since it's in the denominator, current will go down. The units, we have amps for the current, volts for the voltage, and we've got ohms here for the resistance. If you solve that, you can just manipulate that equation a bit and find that resistance is V over I or V equals IR. And this is probably the form most people are comfortable with for Ohm's law. And notice how it looks really close to F equals MA. That's kind of neat. So click here for another video on electricity. Let's go ahead and graph current and voltage and see what we get. Well, we have V equals IR. So if you look at this graph, we have voltage on the y-axis and current on the x-axis. So if we rewrite this a little bit, V over I is equal to R. That also looks like rise over run. So what's the slope of this straight line here in blue? The slope would be the resistance. Notice how it's linear. Now that doesn't work for all materials. If it does work, if the resistance of a material varies as this linear function here, we call it an ohmic material. If it doesn't, as seen in this one, where it curves up, that would be a non-ohmic material. For this course, we're just going to be dealing with ohmic materials. So V will equal IR.